This is All Things ANSYS, a podcast from the technical support staff at PADT. Episode 125, our 2023 year-end wrap-up discussion and news and events from the world of ANSYS. Hey there, welcome to our little podcast and to the month of December. My name is Eric Miller. I'm one of the owners here at PADT, and this has been another one of those years that came and went before I had a chance to get my head around it. I'm actually recording this from the Hampton Inn and Suites at the Denver Tech Center just outside of downtown Denver. I was in town for our holiday dinner for our folks that work out of the Denver office, and getting this recorded before I take a plane back to Phoenix. So apologize for the audio a little bit. I'm just using the microphone on my laptop, so I don't travel with a podcasting mic yet. So this is episode 125 and also our annual wrap-up show where our tech support team talks about the year in review. It's been a while since we did an update on podcast statistics, so let's start there. After we took a break for the second half of 2022, leadership is still going strong with 42,400 downloads or 342 per episode. Our most popular episode is still our interview with John Swanson, the founder of ANSYS. If you have not listened to that yet, we recommend you go back and download episode 35. He is fantastic. If you're an ANSYS user, you have to listen to that podcast. It's wonderful. Our most popular newer episode from 2022 was What's New with Mechanical Meshing, ANSYS 2022 R1 with 567 downloads. In fact, meshing continues to be the most popular topic for mechanical and fluid simulation. So whenever we talk about that, we get a lot of listeners. If you enjoy this podcast, all we ask is you subscribe and recommend it to others. So before we get to the interview, I'd like to express my heartfelt thanks to our partners at ANSYS and our ANSYS customers. It's the end of the year, and it's really fun and intellectually satisfying to do what we do for a living. And we're so fortunate to have spent another year as part of this wonderful world of all things ANSYS. So this year, we actually had 11 of our ANSYS and FlowNext support engineers join us for our roundtable discussion. It was a fun chat, and I hope you enjoy it.
All right. I want to welcome everybody to our kind of annual event, which is end of year discussion about what went on in the world of ANSYS over the past year. So believe it or not, 2023 is coming to an end. I know that everybody, at least most people are surprised at how quickly that happened. I know I am, but here we are, and a lot happened in ANSYS, and this is our turn to kind of look back and think about how it impacts us and things like that. So before we get started into what people think, I'm going to go ahead, since we're virtual, I'm going to go ahead and call on you, and you can just tell us very quickly, your name, what you do for PADT, kind of your area of expertise. So we'll go ahead and start with Miles.
Hey, my name is Miles Adkins. I work in simulation support, application engineering and providing tech support as well. Primarily working with thermal fluid systems and doing analysis around that.
Cool. Very good. And Chris Settanni?
Hey, I'm Chris Settanni. I also work in thermal fluid systems, primarily provide support for FlowNext and some thermal desktop support.
Cool. And although this is all things ANSYS, we do like to talk about FlowNext here, so that's really good. Alex.
Hello there. This is Alex Moody. I'm an application engineer as well. I cover kind of the high frequency electronics, so tools like HFSS, SI wave, anything with high frequency electronics, RF.
Cool. And Robert McCathren.
Hi, I'm Rob. I work on the mechanical AE side. I'm handling most of ANSYS Mechanical, ANSYS Discovery, and I also work with the ANSYS Granta Materials products.
Very cool. And Christian Crowley.
Hey there, just like Rob, I'm a mechanical AE, so mostly working on the structure side. I specialize a little bit in the scripting and the Python applications of mechanical as well.
Very good. Excellent. And Josh.
Hey, I'm Josh Stout, and I'm another application engineer in the support group. I'm a systems engineer here, but I cover kind of the not electronic side of electronics, so reliability and thermal and mechanical, and then our workflow technologies for optimization.
Very cool. Joe.
I'm Joe Woodward, Chief Engineer on our simulation support side. I specialize in Python programming, structural meshing, mostly on the mechanic side.
Great. Ahmed.
Hey, my name is Ahmed Fayad. I work for simulation support as well. I do mostly IT, licensing, and HPC stuff.
And Doug?
Sorry, I walked away from the phone for a quick second. You weren't going in any order that I could.
No, I'm going on the order. It's on my screen. I should have said it's going on the order on my screen, which it seems to be random.
Perfect. I'm Doug Oatis. I'm a old school, I guess now, mechanical APDL user. I'm the pre-sales application. I'm the pre-sales. What am I? I'm the pre-sales engineering manager. There we go.
There we go. Very good.
We did it.
And what's nice is we ended up with Ted at the end here.
Okay, so I'm Ted Harris. I'm the director of our simulation support team here at PADT. Longtime ANSYS user with a background primarily in structural and thermal stuff.
Very good. Excellent. Well, thanks for that, all the introduction. I hope our listeners get a little bit of an idea of how diverse our coverage is. And that's not everybody on the call. We've got folks covering optics and other CFD things and all sorts of stuff that weren't able to make it today. But so big variety. This is just a fraction of the team, but know that here at PADT, we've got everything covered. So the point of this discussion is really talk about what we're excited about from 2023. And I'll kind of throw it out there for whoever wants to go first. What was the most exciting thing that you saw this year in the world of ANSYS or FlowNext for that matter?
Ooh, me first.
Okay, go for it.
I like the geometry-based associativity.
Mm-hmm.
When you swap out parts, it no longer just kind of throws out your boundary conditions, but it looks to see, okay, there's a plane in the same spot, there's a cylinder in the same spot. Let me just map those constraints and things over, name selections and stuff and whatnot. So
that's huge. Yeah.
Definitely will help along the way.
Yeah, because back before, right, it was on some internal numbering scheme, and if that numbering scheme changed, you kind of had to redo everything, right?
Right. Yeah. And I found out along the way, depending on the CAD package that you used,
mm-hmm.
when it converted and created those internal numbering, then that got saved with the CAD file. So if you didn't save the CAD file, then anytime you reopened it wrote new ones all over again.
So this is great. This is something that I remember asking for this is so long ago that I was actually on the advisory committee for ANSYS, and we were looking for this kind of topology and geometry intelligence to say, like you said, oh, there's a cylinder nearby or a surface that's kind of nearby. Let's go ahead and try that. So that's great to see that they got that in there. Not an easy thing to do. So it's good to see that they got it in there.
Yep.
Cool. What next? Who else is excited about something?
Well, I'll go ahead and share something. So on the discovery end of things, because we've had one of our customers have been asking about like modeling in rotating flow for fans and stuff like that. That's in discovery now, as well as the nonlinear contacts are making their way into explore mode. And so they're very heavy into using explore mode over there. So it's good for them to have all that functionality with it because they're modeling things with springs and catches and latches and stuff. So all mechanisms.
Very, very cool. So I think a lot of people, myself included, may think that, well, you can't do that in discovery, but it sounds like we can now.
Yeah, they keep on adding more things.
That's cool. So I could do like a fan. I could do a CFD on like a fan for my cooling.
Well, what they do is they'll allow you to do the rotating fluid flow, but not the rotating fan, as it were. So
right.
Like you can do that, but it's like they were like, hey, we don't just want the flow going out, just one unidirectional kind of a thing. So you can actually
if I know what that looks like, what the rotation looks like coming off my fan, I can put that in. Very cool.
Absolutely.
Wow. Big improvement. Yeah. Good. What else out there?
Just to keep with the structural theme, I'll go next. So first, this is my first year using ANSYS. So everything has been exciting for me, right?
Awesome.
I've had to name one thing though. Again, coming from the Python side, it's actually something I found out yesterday. It was in 23R1. They added a beta option to turn on a C Python interpreter instead of the Iron Python interpreter.
Ooh.
So that's a big game changer for me, at least, because now you can actually use NumPy and SciPy and like your normal Python modules and mechanical scripting. So, and that's not to mention all the stuff they're doing with PyAnsys and PyDPF and all those other side projects as well, or I guess not side projects, like the new standard for those things. But I'm excited that they finally put that in. There's so many modules that I haven't been able to use because of that in the past.
That was a restriction, because you were, so for those that don't know, Iron Python is kind of a commercially supported subset of Python that Ansys, when they started doing customization using Python, kind of bought into. The goal was to get something that was reliable. But as Python has evolved, it looks like they've opened it up to the more standard. And the problem with Iron Python was you couldn't use all these modules that you're used to using that weren't supported in Iron Python. So you're kind of restricted in what you could do. So this is great news. And this is what products? Is that just Mechanical and Workbench, or is it other products as well?
I haven't, again, I found out about this like 2 days ago. So I still haven't explored how far it goes. But from what I can tell, it's just the mechanical scripting.
Right. Good. Very cool. Very, very cool. Love it. What else?
So a couple of things on my end is the new shared web licensing, where for Ansys licensing, you don't even need to set up a license server or fiddle with firewalls and Windows Defender and all that fun stuff. It is still in beta, limited products, but basically you just log in and your software works. So that's one piece of it. The other piece is the improvement with Ansys AWS cloud integration, where they have kind of a light version which sets up rather quickly and doesn't require a few hours of IT expertise to set up.
Very cool. Yeah. And we just had a podcast on that. So if you want to know more, we had some good discussions on that and other new stuff on the licensing world. So we can get into more depth on that. Cool.
I'll go next.
Yeah.
All right. So I'm going to hit two like very obscure things. One of them is the ability. So one of the problems in Mechanical, when you have a really refined mesh and you zoom out, all that happens is that the part looks black because all the element edges collapse. It always shades the element edge as a black line. And so a really refined mesh just looks like it's a black hole. And so you can actually change that now. It actually shows up as the color of the body.
So
it's like this very minor, like little thing, but it's
kind of big. Yeah.
It's like, oh, I was only looking out of my right eye like the entire time. Like it's kind of a nice thing to have. And then the other thing that I found out, I don't know if it's documented anywhere or anything like that, but I had done a blog post about spatially varying material properties, and that uses like some field variables and the INI state command in order to kind of map that all over. So this grew into an engagement with a company where we were playing around with time varying material properties. So not temperature. So this is like, think of like ablation modeling or something like that. And so typically in order to access that kind of functionality, you would need a UDF, and UDF requires you to, it's like a force. Yeah, it is. You got to send it. Yeah, you got to listen to the radio show, get the code, mail that in. You get that back, then you install something else. Then you call your friend, and they do. It's not that bad, but it is a multi-step process in order to, write and compile everything. But in 2023 R2, you can redo the INI state variable between load steps. And so between load steps, you can do a step variation on your INI state for a field variable without having to go to a UDF. And so it's kind of, it kind of works. And it's kind of a cool little thing that like, this was one of those cases where I'm like, oh yeah, this works. Here you go, customer. And they, are using not 2023 R2. And so obviously it didn't work. And so that's how I went down the UDF, and that was that. Full disclosure, cool. I've been at PADT for 17 years, and this was my first time working with UDFs, and so I've made it that long. But yeah, so being able to change an INI state not in the first load step is actually a pretty cool feature.
That is kind of an important thing. Yeah, is that covered in the documentation?
I didn't look very hard, but it was
okay.
me.
Okay. Well, if this piques your interest, reach out, listeners. Reach out, and we can help try to figure out what's going on there.
Yeah.
Very cool. Yeah, that's kind of a big deal. And the CFD guys are kind of like, well, we've been able to do stuff like that for a while, but yeah. What else?
I'll jump in if no one else has anything.
Go ahead, Alex.
Go ahead, Alex.
Sorry, Josh, if I jumped in, but yeah, just on the electronics side, I would say the big thing for me that I thought was really great for HFSS was it now is able to handle semi-rigid PCBs. So a printed circuit board's, historically like a rigid structure. It's like a rectangular shape. It's all these layers sandwiched together, and it's, you can't really bend it or flex it. But there's been advances over the last several years in technology for manufacturing to make these printed circuit boards on flexible material that can be bent and conform to different shapes. And that's convenient for a number of reasons. One being you can cram into smaller enclosures. Yeah. But there wasn't a good way to simulate it because most of the ANSYS tools were still assuming that you had these old rigid kind of layers of your printed circuit board. But in 2023 R1, there was a beta for a semi-rigid simulation, which actually lets you take a PCB and bend it to any arbitrary angle, as many bends as you'd like, and you can actually simulate that as a full 3D solver. And that's actually exited beta as of 2023 R2. So that's a fully integrated feature now in HFSS.
That is kind of a big deal. For those who don't work in that space, the inside of your phone is full of these flexible circuits, in order to get it packed into that tiny little space. And I know that's always been an issue, is being able to model that three-dimensional geometry when it's in the distorted shape. So that is very good news. Cool.
That was the first thing I thought of when you said foldable things. Was the foldable cell phones now. But
that too. I wasn't even thinking about that, but you can actually fold the screen now. Yeah. It makes me cringe every time I see somebody do it like it's going to break. I'm definitely wired that screens are fragile. That's so funny. Josh, you had something.
Yeah, so actually Alex's topic is a great segue to this. But Sherlock has seen some more additions this past year around multi-PCB assemblies especially. They've really fine-tuned the workbench integration. So you can actually set up multiple PCBs that are connected to each other inside of a chassis and analyze them all together in the larger system, and then pass those results into Sherlock to get results for an individual board. So that used to be a pretty messy process, but they've really fine-tuned it. And of course, the other part of that, as Alex mentioned, is flexible PCBs are becoming more and more important for analysis. So they've expanded on the mechanical side the kinds of analyses that we can send the trace reinforcement models through. So you can get a lot better resolution on those as they're bending around, especially.
Okay. Really, so just more accuracy, easier work. Good.
Yep.
Yeah. Cool.
That trace mapping makes me mad because I used to fight that. So the only way around that in the past was you had to chop up your board into discrete sections in order to get the traces, somehow available on an element by element basis. And the reinforcement makes it angrily easy to me.
Yeah. I know these kids today don't have to walk back and forth in the snow uphill both ways anymore.
Exactly.
Any CFT guys on the call? I joined kind of late. Oh, sorry, Joe. Go ahead.
No, go ahead. Glad you're here.
Sorry. Welcome. I'm so glad you could bring. We've had a dearth of CFD excitement. So what are you excited about in the world of CFD?
Yeah, so this year, obviously, the GPU is a big thing for all the different fields of simulation, and fluids dynamic is definitely not an exception. But I guess this year was the native GPU solver in Fluent, which I think it's actually a good point to mention that it's a very general Navier-Stokes GPU solver. So other tools might be like developing GPU capabilities, but they're very specific on each areas and applications. And this is a very general GPU solver. So I think this year it got to the point that we had more customers interested in using it. Obviously, the first couple of years always like fundamental of physics, not necessarily more complicated things, but they kept adding to it, and they will keep adding to it. But this year was kind of to the point that some of the users, even advanced users, could take advantage of GPU. And the thing that I really like about the ANSYS looks at about GPU solver. GPU solver is part of a more general bigger picture, more general view of fast simulation. It's not just like rushing. Everyone's talking about GPU. They're not rushing to GPU because of that. It's again part of a more bigger picture of faster simulations. And aligned with that, one of the features I really liked in Fluent this year was a fast setup. So before, if you had like a big heavy case and you wanted to change some of the settings and solver settings, like some of the inlet boundary conditions, like changing the velocity inlet, you had to load the whole mesh and then open the case and change the setup. And now there's this feature that if there's the mesh topology is not going to change and you're only changing something in the setup, you can only load the setup case, which takes only a few minutes, even if you have like a few million cells of mesh, and then continuing running the case. So the fast simulation is definitely a focus for CFD and Fluent this year and the coming years. And this is, I think everyone likes it.
That is great to hear. All right. Good.
I was
go ahead,
surprised to find out, they quoted some numbers in our big customer meeting not too long ago that one GPU is about 300 to 500 CPUs.
Wow.
That I was not aware of.
Big.
So at least on the CFD side, those numbers were getting quoted. So
now if we can just get the AI people to stop taking all the GPUs, we can get them, right? Good.
Exactly.
So I'll toss something in there. Kind of Cynthia's out of the office today. De La Rosa, who's been on the podcast a couple times, and she's of course our optics engineer. One of the things she talked to me about earlier a couple weeks ago that she was excited about is more of a general. And Ted, I don't know if you or others can talk to this a little bit more. Is how the integration between the ZMAX products and the ANSYS products, and as well as numerical and things like that, are coming along to where it's just all fitting together better, so you can move between the different tools much more easily. I don't know if anybody's got any experience to talk about that, or we'll just leave it as a statement.
Just kind of general, it just seems that ANSYS is doing a much better job of integrating tools.
Yep.
Much faster. It used to be, okay, we bought this company and eventually it gets integrated, but it would be 4 or 5 versions out.
Right.
Now it seems the next version, it's at least partially integrated in, whatever the code is, it gets, at least they have the background in place to put these things back in very quickly.
So I feel that's a great segue into my list, Joe.
Great.
So besides ZMAX now running in the ANSYS License Manager with most of the other ANSYS tools. Also this year, we saw Thermal Desktop become available within the ANSYS License Manager. So, 2 fairly recent acquisitions that are already rolled into the ANSYS licensing system. And, we expect to see tighter integration on the tool side with the other ANSYS products as we go forward as well. Themes that others have been talking about: faster, more accurate solutions, a lot of that involving GPU, but also, enhancements to the code to take advantage of faster and more accurate capabilities. One example I can think of right now is in turbomachinery, multi-stage cyclic symmetry. So years ago, 2D was really all you could do. It was really before my time. And then 3D wedge gave you a lot more accuracy, but we could only solve a single stage at a time. So in the last few years, ANSYS has been rolling out multi-stage cyclic symmetry. So that allows for a lot of accuracy because it's not 2D, but the ability to solve more than one rotor at a time with different symmetry counts due to different blade counts in each rotor. So big advancement in accuracy and speed. Other things on my list. So Eric mentioned optics a little bit, and since Cynthia isn't here, I thought I'd mention just a little bit more. So Lumerical, seeing some really nice speed ups, and then some enhanced workflows for ZMax involving symmetry to speed up simulations, make them more efficient. Another thing I had on my list was the discovery tool for geometry modeling. I mean, for many years now, SpaceClaim has been the geometry tool of choice for most ANSYS users. That's where most of the development has been. But now we're seeing a transition into discovery. So I think a lot of people think of discovery as, oh, that's that fast simulation tool that solves on the GPU. Well, that's true, but it does a lot more than that. So it does solve on a GPU, but it also has more traditional solvers for greater accuracy, and certainly the ability to move into the ANSYS flagship tools like Mechanical and Fluent. But it also has geometry creation, geometry editing ability, very much like what we've had in SpaceClaim for quite a few years. And if you're familiar with geometry manipulation in SpaceClaim, you'll be familiar with it in Discovery too, because the menu system is very similar, user interface is very similar, but modernized. And there's a different geometry kernel, which helps out in a lot of areas as well.
Yeah, that's the big one. Helps with translations back into mechanical and things like that.
So to go to Parasolid or vice versa?
Yeah, Parasolid.
Okay. Good.
And on the PADT side, I just thought, I'd point out, this is a year that we've really hit our stride on optics, with having an optics engineer from the get-go. I mean, she joined us last year, but our ability to sell and support the optics products really came into stride this year, with certification not only in ZMax and SCADE, but also Lumerical. And we also have SCADE ability now too. And I know Noah is not on the call, but Noah got the SCADE certification earlier this year, one of our newer hires. So super happy that we have that family of ANSYS products available to us. And Noah just released his first blog article on SCADE. And if you don't know what that is, check out the PADT blog and you'll find out more.
He's actually promoting world domination with SCADE. So it's actually a very informative, but also humorous article. So definitely check that out on our blog. Yeah,
he's already started building his robot army.
Yes, exactly right. That's exactly right. Cool. That's really a great summary. Anybody have anything else? One thing before I ask again is, last year we had a lot of acquisitions in 2022. It was Rocky DEM, Motor Design Limited, which is MotorCAD, right? And then CNR, which is Thermal Desktop, and some other tools, and then OnScale, which is basically a web-based simulation platform, or cloud-based simulation platform. This year is a little less exciting. They bought Diacopto, which is, I think, an EDA, an electronic design tool. So I don't really know anything about it. Does anybody here know anything about Diacopto? I don't think so. So one area of ANSYS we don't get into too much. And then I think a really strategic one we're going to get more from is they purchased Dynamore, which was a huge Dyna. We bought ANSYS bought LS Dyna a few years ago, and Dynamore is a giant partner of LSTC, and now ANSYS is now part of the ANSYS family. They have a whole slew of tools and add-ons and all sorts of great stuff that works with the Dyna platform. So I think we're going to see a lot come out of that acquisition of the folks in Stuttgart at Dynamore. I know it's been great for us.
Yep. And three of those tools you just mentioned, Eric, I did not mention on my list of new capabilities to PADT, and those are Dyna, MotorCat and Rocky, and that's because we've had familiarity with those.
Yes.
For Dyna for many, many years, and for the others for the last couple of years. So I didn't want to slight anyone on our team, but
it's a lot to talk about. I mean, it's fantastic. Right. The diversity of tools is amazing across physics and applications, and it's not slowing down, right? We haven't mentioned Granta. That's one of my favorite tools. I won't say it's a new acquisition. It's been a while. Anything new and exciting in the Granta world?
Well, they just keep on, building and curating their existing libraries.
Great.
They're pushing more into the kind of electronic side in terms of support for MDS, not just materials data for simulation. That's all those kind of existing pre-made libraries for ANSYS materials. I think additionally, there is more work on the MI Pro side of things. That's Granta Materials Intelligence. The pro level is kind of like, the introductory kind of level to it. Like I'm going to be building my own databases. I'm going to be, pushing those out. I think so far as the cool tools that are associated with that, there was one that was kind of like a almost George Jetson-ish kind of click to take your test data into a nonlinear material model and have it ready to go for ANSYS. So it does all sorts of curve fitting and fun things. So if you have this data and you don't have to like generate that in for it, it'll do that for you.
Very cool. Wow. It's coming along. Huh.
Mm-hmm.
So I'll just ask one more time. I want to conclude with your predictions for the future to see how wrong we can be. But before we do that, anybody else have anything they want to share?
Yeah, I'll hop in if that's all right.
Yeah, please.
So, this kind of gets back to what Ted was talking about, integrations between different ANSYS softwares. And one of the big improvements that I've seen and had firsthand experience with in the last year was an improvement to the link between ANSYS Mechanical and Flownex. So now you're able to retrieve name selections automatically for the coupled solves. So it really helps if you're doing, a coupled solve between, Flownex. We're using Flownex for 1D, thermal hydraulics, and then like an ANSYS Mechanical for either structural or thermal analysis, and capitalizing on the speed of 1D, but not compromising on accuracy by doing 3D where needed in ANSYS Mechanical. And that workflow has been improved significantly in the last year. Through various improvements, including those automatic transfer of name selections.
It's great to hear. I love that. Yeah, more and more integration there would be good. Anybody else?
Yeah, I'll if I can add my 2 cents. I'm definitely excited on the Flownex front to see the addition of batch runs, which enable users to run essentially parallelized runs and plot data on the same graph. So you can, if you're running a water hammer analysis, you can vary valve closure time and see how that like a pressure profile past the valve differs with time. That was really exciting to see because that's a big time saver. And on the integration side, I think the addition of Python functions to Flownex integrated scripts is a pretty exciting addition to the Flownex family.
Okay, cool. Very cool. Okay. What else? All right. So now put on your prognosticator hat. What do you think is going to be the big thing we'll be talking about at this time next year?
AI.
Yeah, you stole I was going to say AI too. Good or bad, whether it's working or not, we're going to be talking about it.
Right, exactly.
And the other half of that is ML.
Right.
Machine learning, right? Yes.
Yeah.
Yeah, I'll go a little bit deeper into that because before we actually started recording, while we were waiting for some folks to leave another meeting and join us, we were talking about. I think it's really as a little advice to listeners as we move into 2024 and AI creeps its way into our world of simulation. It's really important to make a distinction between machine learning and generative AI. They're very different technologies, and expert systems, which are still a thing, right? And I think it's really important to know that difference because how they're going to impact us as users is going to be very, very different. And machine learning, I think, is going to be the one we're going to be talking about the most. And we'll have some cool applications for generative, hopefully coming out next year that'll help the user experience as well, but we'll see. Yeah. Well, Ahmed.
Okay, so this is not something I'm an expert in, but considering where the world is going and how sophisticated consumer products have become, I think Medini, like risk assessment and the safety aspects and the cybersecurity simulation aspects are going to kind of come in more in line as the hackers and the hacker kind of environment develops and kind of catches on that these smart devices and cars and all these things are online now and we could hack them. I think that's going to be a thing this coming year.
Yeah, we haven't even talked about that product line, but we are seeing that become more and more important from a cybersecurity standpoint, like you say. Yeah. Simulation is a place everywhere. Anybody else? Any predictions on meshing? Are we going to see meshing get better next year?
Of course.
Every year.
Definitely. Every year. Yeah. For sure.
I guess one other thing I can maybe just predict on, kind of like Ahmed said, I'm not specifically an expert in this area, but automotive space is becoming much bigger in simulation, especially the self-driving vehicles. So I think there's going to be a bigger emphasis on sensors and how those sensors integrate with systems, and then all of the simulation that needs to be done for the physics of those sensors, whether that's mechanical, thermal, reliability, that kind of thing.
Yeah. I think you're very right about that. And I don't think that's going to stop anytime soon. I think and it goes, so we're seeing a lot of growth in our customer base in what we call new space, right? And sensors play a really important role there as well. And it's multi-physics, right? It's optics, it's high frequency electromagnetics, low frequency electromagnetics, structural, thermal, fluids, it's everything. Yeah. And controls, it's systems, it's everything.
I'm really curious to see how integrations into SDK evolve over the next year. I think that was AGI a 2022 acquisition? Is that right?
Or 21, yeah.
Or 21, but like as it's become more integrated into the ANSYS ecosystem, those integrations are becoming more and more robust, and it's just really cool to see what folks are doing with that tool.
2020, actually, yeah, 2020.
We haven't talked a whole lot about optimization, but certainly there's OptiSlang and also Model Center, and there are individual tools within certain physics for optimization, but model-based systems engineering, digital thread, we're seeing more and more of that. Companies more and more interested in that.
The reality of it, yeah. What about hypersonics? I know we've made a lot of strides in hypersonics. Is that something you think is going to be a big jump forward, or is it just kind of continue to evolutionary growth in hypersonics?
Well, our hypersonics expert isn't on the call right now. But,
I think, yeah. So eventually, GPU would capture that part also. Yeah, whether it's going to happen 2024 or not. I'm not sure, but that would be the big jump, obviously, for hypersonics.
A lot of enhancement has gone into Fluent for hypersonics recently.
Yeah. Recently, yeah. I think the big leap was, to my understanding, was this year, especially, but it's been ongoing for several years, and hopefully will continue because the demand keeps going up for that. Cool. Anybody else want to make a bold prediction? Anybody want to predict who ANSYS is going to acquire next? I only got it right once when I said LS Dyna for like 5 years or 3 years in a row, and finally they did it. So I got it right one year.
There was one year I predicted self-driving cars on Mars and something else, and that has happened. And we also have a self-flying helicopter on Mars this year. So
that's right. Yeah.
My prediction in general, I think I might be wrong, but I think there's obviously a big interest in EVs.
Yes.
But I think eventually hydrogen might also come back in the future. Yeah.
Yep. It's got to at some point. Yeah.
Yeah.
And I think modular nuclear reactors, we're seeing that grow as well. I don't know if 2024 is going to be the big breakthrough year for them, but yeah, along those same lines. Yeah, I think it'll be interesting to see. I'm going to predict some big play on the systems modeling side. We've made some acquisitions in that area that are paying off. I think AGI can be considered that. I think that Skate is kind of along those lines, but I think something that's more of a very large system modeling tool that you could maybe use for. I'm thinking of those tools you use to like model large crowds or traffic or big complex factory floors, those kind of simulation tools. I'm gonna predict something in that area. We'll see.
Now, if you're going in that direction, I could maybe go in the opposite direction.
Okay.
So my grad background is in molecular dynamics, so that's still kind of near and dear to me. And
yes.
Something that ANSYS has kind of been missing.
Yes.
So I keep waiting just to see, maybe someday they'll pick up a molecular dynamics tool.
Yeah, and one could argue that what's the combustion company they bought?
I was going to say that's just an add-on package for Rocky in the future.
No, not that one.
You somehow
just keep getting smaller and smaller. Just change the units. No. Yeah. The thing, the product that runs into KinChem. Right. That's a very specific molecular dynamics tool, right? No, maybe not exactly the same thing you're talking about. Yeah, combustion chemistry.
It's more chemistry than that.
That's more chemistry. You're right.
Yeah.
So I'm trying to think of the company that came out of that was in San Diego that got acquired by somebody else that was kind of the leader that the pharmacy guys love. It's in that area. Yeah. That's a good one. I'd like to see that. Then we can go. Then we need something that has relativistic solving capability, and then we're going to do the whole spectrum, right? Cool. Anybody else have anything else? Well, I always love these sessions. I love thinking about the past and the future and where we've been and where we're headed. I hope everybody had a good 2023, and here's looking to a little less chaos in 2024, and hopefully a fantastic year for everybody out there listening, as well as everybody here at PADT and all of our friends at ANSYS and Flownex. So thanks again, everybody.
Thank you.
Cheers. Yep. Thanks.
We'll talk to you guys later. Thank you.
And hopefully you learned about some useful new features you were not aware of before. And as you can see, we're lucky to have such a diverse group of experts on our team. And speaking of which, for this week's commercial, I want to ask if you think you might be a good fit for the team, or if you know someone who is. We've got 2 open positions on the technical support, application engineer and technical support team for ANSYS sales. The first is the application and support engineer, structural. And I'll just read you the job description. The application and support, The application and simulation support engineer provides technical expertise to support PADT's customers, while also assisting those customers and the ANSYS sales team through strategic pre-sales and technical scoping activities, utilizing engineering knowledge, simulation experience, problem-solving, enthusiasm, written and verbal communication, and eagerness to learn. So for this particular position, experience in simulation using LS Dyna is required. So it can be either LSTC LS Dyna or ANSYS LS Dyna, with automotive crash simulation a plus. So we're looking for somebody that's really an LS Dyna expert that can help us with our customers that are doing automotive crash, as well as many other applications for LS Dyna. The second position that's open is model-based system engineer. And so I'll read that to you. MBSE, Model Center Engineer, provides technical expertise in model-based systems engineering and specifically ANSYS Model Center software. The successful candidate will be able to assist with customer support questions, demonstration preparation, and other pre- and post-sales functions, as well as be able to assist PADT's other engineers with Learning Model Center and its application, utilizing engineering knowledge, simulation expertise, problem-solving enthusiasm, and written and verbal communication, and as well as that eagerness to learn and teach, which you, of course, just heard with our group here, right? So if you're an experienced LS-DYNA or Model Center user and you think you would be a great fit for our team, head on over to www.padtinc.com and click on the About button at the top, and then click on Careers and learn more. The jobs are posted there along with other ones, and apply. You or someone you recommend this job to may be on our 2024 roundup. You never know. So let's take a look at ANSYS news. ANSYS stock is sitting at $296.36 after the market closed on 12/12/2023. That is up 20.4% year to date and 22.4% over the past 12 months. So the S&P at that point was up 17.5. I will say, since I wrote these statistics down, the market did hit an all-time high, so these are a little out of date. But anyway, it's been up 17.5% over the last 12 months. So ANSYS is outperforming the general market of the S&P 500. So that's fantastic news. And hopefully on its way back to get above that all-time high, just over $400 per share. So we've got a ways to go, but I have faith that we're going to get there. In ANSYS News, there's a really good story in their news area called ANSYS Enables NuScale Power to Develop Advanced Nuclear Technology. So NuScale is somebody that we work with on the FlowNext side. They work with ANSYS Direct, I believe, on the ANSYS side of things, and they're building one of these modular nuclear reactors. And they're growing and doing better. And the article, there's basically a press release on how ANSYS is enabling that technology. So if you're in the nuclear alternative energy space, I highly recommend you go to ANSYS News and check that out. And then the other bit of news worth sharing is that, once again, ANSYS won an award. Newsweek named ANSYS to America's most responsible companies for their 2024 list. And what is notable is not just that they got that award, but it was the 21st award of 2023 that they won. So, definitely people are taking notice that ANSYS is a different company and doing some amazing things, and that we as customers and resellers have known for a long time. So speaking of awards and PADT news, I was surprised to learn that I actually made a list of the top 19 leaders in the Phoenix business community. I'm just finishing up my 2 terms, 4 years, as chairman of the Arizona Technology Council Board of Directors. And I continue to write in the Business Journal and mentor through the Arizona Commerce Authority and the Clean Tech Open. And I guess they thought that was good stuff. So it's a true honor that really highlights the work of all the people in each of those organizations that really let me play with them. It's a true joy to work with those different groups and do stuff in the community. So I really appreciate that. In publication-wise, the ANSYS blog, I've picked 3 articles that I think are of note over the last month. The first one is called Imagining a Hydrogen-Powered Future Thanks to Simulation. And just as the title says, it's a look at using ANSYS simulation tools to enable all of the things that need to be done for a hydrogen-powered future, right? So this whole electrification with batteries is a good step in the right direction, but in the long run, we really need to get to a hydrogen economy. And there's a lot that goes into that: infrastructure, extraction, transport, delivery, storage on the vehicle, and then the actual energy extraction from the hydrogen, how we're going to use it. So lots there. A really good article is kind of where we are in the simulation world for hydrogen. The other one I recommend is Getting to Know Design Optimization, and it's a look at, the reason why I pointed it out is we've talked about optimization tools in ANSYS for a while, and OptiSlang in particular in the ANSYS suite. But what I liked about this article and why I recommend it is we're starting to see artificial intelligence and machine learning algorithms making their way into the ANSYS optimization tools. So this is about how AI and ML are used in OptiSlang. So check that out if you're curious as to where this burgeoning technology or exploding technology is being used in the ANSYS world. And I think we'll see it first in the optimization tools. And then the third one was kind of interesting to me. It's called Breaking the Cycle of Brake Dust Emissions. And, my son's older Saab has this problem in that there's brake dust everywhere. it's an issue, and with so many bazillion of cars out there and more coming out as it is, the particles that come off of brakes are becoming an issue. And so ANSYS has made a lot of efforts in modeling brake systems, and we always talk about squeal, and we talk about all sorts of other things in brake system design, but this is a look at using fluid simulation to look at brake dust emissions. So if you're in the brake world or care about emissions of any kind, do check that one out. For the PADT blog, I've got 2 articles that I want to highlight that I'm really excited about because I learned a ton, and they're called World Domination with ANSYS SCADE, and it's part 1 and part 2 of that. So one of our newer engineers, Noah Asher-Brannard, is a SCADE expert. He's an embedded systems guy and robotics guy, and he wrote these really good articles, and they're funny as well, which I always like, about how to use ANSYS SCADE as a software development platform for your embedded systems programming. So in the first one, he kind of gives an overview of SCADE. And in the second one, he actually shows how you can use SCADE to program an Arduino. And what's cool is you don't really write code. You create a flow of what you want the thing to do, and it actually certifies and writes the code for you. And then you can, of course, simulate it because it's ANSYS. So pretty cool stuff. If you want to know more about ANSYS SCADE, check that out. So that's the only real blog article we've got since the last time we talked worth pointing out. Event-wise, we've got nothing through the end of the year, so everybody can relax a little bit. We do shut down mostly. Our sales and support team does work between Christmas and New Year, but most of us take off that time. We'll be kicking off 2024 with, as usual, with the Arizona Photonics Days down in Tucson, Arizona. That's January 24th to 26th. Our very own optics engineer who's been on the podcast, Cynthia De La Rosa, is going to be talking about ANSYS and optics. And this is not just a regional event. This is an event that people from around the world come to. Photonics West is the next week. That's the big international show. And so on their way to Photonics West, they like to come and do some technical confabbing in Tucson, in the Optics Valley there, which is the leading area in North America for optics. And then the other event that I got on the calendar coming up in the first 3 months is IME West in Anaheim. So we'll have a booth there again like we did for the last couple of years. And we look forward to seeing people. If you're going to IME West, the Specific Design Show, MD&M, and there's a couple other names that kind of combine them together into one show called IME West. We'll be there. Stop by the booth and say hi. We'd love to do that. That's it for our podcast today. I want to thank you for joining us and putting up with my cheap microphone on my laptop. Don't forget to subscribe to www.padtinc.com/opt-in. That's described to our newsletter, so you can keep up to date on everything going on at PADT. And do spread the word. Subscribe to this podcast as well. And don't hesitate to reach out. Thank you for joining us for the All Things ANSYS podcast, episode 125. As a reminder, this podcast is not affiliated in any way with ANSYS Inc., and the opinions expressed are those of the people on the show only and not of their current or former employers. For more information, visit www.padtinc.com/blog, and please share your thoughts and questions through email to podcast@padtinc.com. See you next time.